In this chapter, we will be looking at polynomial functions. In this chapter, we will be working with polynomial regression equations.
All right, so as we said here, what we're going to do is we're going to be looking at polynomial regression, okay? And so there are three different types right now in this particular course that you're going to look at. We're going to look at linear regression, quadratic regression, and cubic regression. Now, if you're not entirely sure what regression means, it's actually an idea that you are familiar with. Because I'm sure you've done it in a science class where you've had, like, you've taken a bunch of measurements, you've got a bunch of dots there, and then you took out your ruler, kind of like this thing right here, and you kind of laid it out here and drew a line through it to get the line of best fit. Well, that's really what a regression is, okay? We're taking the data and regressing back to a line that best models the relationship between the independent and dependent variables here. Now, sometimes the relationship isn't quite linear. Now, for the most part, your experience, I would think, in science has been linear relationship, but it doesn't have to be. It can be quadratic or cubic. It can be all sorts of different things, okay? And so we're going to look at how the calculator does this. Now, what's nice about using the calculator for this is if you were to do a regression by hand, like you would have done in a science class, you and your friend would very likely get two lines that are relatively close to each other, but they wouldn't be the same. There would always be a little bit of variation here. But when we start doing regression algorithms here, applying these things, then we know that everybody, if you use the same data, is going to get the same result. And so it leads to the kind of a uniform approach to it, which makes it really, really quite useful. So now you've got these different regressions here. Let's just talk really quickly about how you would do it, and then we'll do some examples in a bit. And so you've got a description here, and so let me just kind of walk you through this. What you're going to do first of all is you got to get the data in there. And so to do that, we're going to press the Stat button, which opens up a menu that looks like this. And then we're going to press Enter on Edit. Now, I've already got some data in there, okay? But you're going to put your list 1 in here, your list 2 in here. Now, I'm going to help you out with a couple of things here because I've got some data in there. I'm going to have to get rid of it. So let me show you what you do to get rid of the data here. You're going to use the arrow key to go up to the list, L2. And then I'm going to press Clear. Now watch what happens when I press Clear. Okay, press Clear. What happens here? Down here, prior to me pressing Clear, it had a list of all of the items here with commas separating it here. So now what it does is it clears that out here, and it's kind of waiting for me to confirm, is that what you really wanted to do? And now I press Enter, and it gets rid of the list. So now I'm going to come up here, and you can see exactly what I meant by that. It gives you a list of all the data right there, okay, down here. Now, you could do something here to make things a little bit more stressful for yourself here. Let's say that you weren't really paying attention and instead you pressed to delete. Now watch this. I'm going to press delete here. Now, hopefully you got a chance to see what happened up here. What it did is it deleted list 1. It got rid of list 1. Okay? Now, but you kind of want list 1 in there, so now you might think, oh, great, now I got to put list 1 back in there. Well, this is how you do it. The opposite of delete is insert. So I would press second, delete. Now what that's going to do here is it's going to open up a column next to L2, just to the left of L2. It's waiting for me to name it. And down here above your numbers here, those are the names of the list. So I'm going to press second number 1 to call it list 1. That's our name. I'm going to press Enter. And notice that it didn't delete this list. It just hid it from me. So now I'm going to get rid of that by pressing Clear and then Enter. Okay, so that's where you're going to put your data. Once your data is in, how do you do the regression? Well, again, you press Stat, and this time we're going to go over to the Calc menu, and this is where all of your regression models are. Now, the first two deal with statistical analysis of what's in the list here. The two lists there, or however many lists you've got there, but from this point on, it becomes regression equations. We are going to be interested in the linear regression, the quadratic regression, and the cubic regression. Okay? So now, once that's done, you're going to want to be able to graph this thing. Okay? Now, to graph something, we need it to be into the y equals. And so that's what this is about right here. This is what this is about here. So I'm going to show you really quickly, talk this thing through. Then I'm going to model it a few times with some different questions here. But press y equals. Now, I've already got some data in there, so I'm going to clear those out. Then I've got a clean screen here. To put the regression equation in here after you found it, and I can't emphasize that enough, you have to do the regression equation first before you can do what I'm about to do here. But to put the regression equation here, you would press your vars button, okay, which is right there. I love that particular feature on the calculator because your calculator stores a lot of things in variables. It remembers a lot of what you're doing. And so you don't have to write a lot down. The calculator remembers it. So now we pressed vars. We've been working with a statistical, with a stat feature. So this is a statistical variable, okay? And although we're not doing a lot of statistical analysis here, if you go over to the EQ menu here, your very first option is regression equation. Now I'm going to press enter here and you're going to see it put a regression equation here. Now the reason for that is because I have used this in the not too distant past here. Oh no, it forgot. Oh, that's really interesting. Without the data in there, it forgot it. That's kind of neat. I was expecting it just to have an old one still stored in there. But anyway, once you had pressed that enter there, it would have put that regression equation in that Y1 and then you can graph it. Okay, let's take a look at some examples.
Determine the equation of the linear regression function for the data. Round all answers to the nearest hundredth.
So in this question here, we're asked to do a linear regression and here's our data. Okay, so first of all, we're going to enter the data in. Now, I'm going to make sure that you can just kind of see the two columns here. So again, I press the stat button and we're going to press enter on edit. Now you can just barely see that off the screen here, but that's enough for you to see list 1 and list 2 and that's what I need. So list 1 is always going to be the x coordinate here. So 10, enter, 20, enter, 30, enter, 40, enter, 50, enter. Now notice what it does here, 80, enter, 100, enter. Bit of a jump there. And then my y coordinates will all go in list 2. So negative 3.5, enter, negative 1.2, enter, 0.2, enter, negative 0.1, enter, 0.8, enter, 3.7, enter, 5.2, enter. And so there's our data. You can see it all matches up here. And it's important that it matches up, okay? If you're entering stuff in and inadvertently you forget to enter something in and your lists don't match, and let's say that you don't even notice it happening, when you do a regression calculation, you're going to get a dim mismatch error. Okay, let's just say dim mismatch, and that's your clue. Oh, I must have missed something as I was entering stuff in because the lists aren't the same length. Okay, now we're going to do a linear regression here. So we're going to first of all quit out of here. Okay, I'm going to press stat again. And this time we're going to go over to the calc menu. And although there's a few different linear regressions models that we can use here, the one that we want is this one here, number 4. So press that. Now, my calculator automatically opens up a screen that looks like this. Now, if you've got an older version of this calculator, it won't. It's probably just going to say linreg and then be waiting for you. Now, by default, your calculator treats list 1 as the X list, list 2 as the Y list. If that's not true, then you need to tell it what the lists are, and then what you would do is you would press second whatever. Like let's say I put my X list in L3 and my Y list in L5. I would have to press second 3 and then comma right here, second, what was it, 5 that I said. But for most of us, that's not going to be the case. We're going to put X in list 1, Y in list 2. I'm going to come down here, choose calculate, and so there we go. So what the calculator does is it gives us the equation model in that form, and then it tells us what A is and what B is. Now, I have the calculator giving me a little bit more information here because I've turned on a feature on your calculator. And what this is telling me, my R squared in particular, is telling me how close this is. Now, it's a little bit difficult to understand here, but just to give you a basic understanding, like this isn't necessarily true, but a basic understanding, this is like saying, this R squared is saying that it's about 95, 96% accurate. It's not exactly true, but that's probably a good way to see it. The closer this is to 1, the better this regression model is. Now, if you don't get those for the time being, I think that's okay. So my answer here to the nearest hundredth is going to be y equals 0.09. Oh, was that negative? No, it wasn't. 0.09x. Okay, that's my ax. Here's my a, and then it's going to be plus b. And now b in this case was 3.42. So minus 3.42. So there's my regression model. Whoops, right there.
Determine the equation of the quadratic regression function for the data. Round all values to the nearest hundredth.
All right, now for this question here, we're being asked to find a quadratic model. We got new data. Okay, so again, I'm going to put my calculator here and then make sure that we have just enough that we can see the data here. So stat, edit. Oh, but look, my old data is there from the previous question. So what I'll do here is go up to list 2, clear, enter, go up to list 1. Now, normally what I'd like to do is be lazy and kind of reuse that data here, but it is different. It's not the same. So clear, enter, just to start from scratch. And now my x values here go from 0 all the way up to 8. So 0, 2, 2, 3, up to 8 there. And now go over to list 2. What do we got here? 80, 70, 60, 60, 75, 90, 120, 175, and then 255. Just want to make sure that I put that in right. 80, 70, 60, 60, 75, 90. Yeah. Okay, good. Okay, now we're going to come up with the model here. So first of all, I'm going to quit out of there. And I'm going to press Stat once again, over to the calculation menu. And now I'm going to go down to my quadratic regression, quadreg, choose that. Again, by default, it chooses list 1 as the X list, list 2 as the Y list. So I'm just going to go down there, press enter on calculate, thinks a little bit. It gives me the model, the form of the model, and it tells me what my different variables are. And again, remember I've got this little r squared turning on there, just to tell me how good the model is. So now, over here, I'm going to say that my equation will be y equals, okay, ax squared. A is going to be 6.07 when I round it. Plus bx. B is negative 29.11, so negative 29.11x. And then c was 88.39, so plus 88.39. That's the equation, the regression equation for this data.
Determine the equation of the cubic regression function for the data to the thousandth. Use the equation to extrapolate the value of y when x is equal to 50. Round your answer to the nearest whole number.
All right, this next question is going to ease us into some more applications with this. We're going to come up with a cubic regression for this, and then we're going to use it to figure out what the value of y is when x is 50. Now, yeah, well, please, watch what I do here and the two different things that I do here, okay? So first of all, let's take that data and we're going to plug it in. Okay, so again, I'm going to give myself some room here. Stat, enter on edit, and again, there's my old data from the previous question, so clear, enter, and now I'm going to enter in the data, so 5, 10, 15, 20, 25, 30, 35, 40. Okay, and then 211, 236, 255, 258, 264, 267, 276, and finally 291. I'm just going to double check that I've entered that in correctly. It's looking good. 264, 267, 276. Okay, so now I'm going to quit out of there, and we're going to do the cubic regression. So stat, calc, and then down to the cubic regression. And just like before, it defaults to list 1, list 2. So I just got to come down to calculate, and here we go. Again, there's the form of the equation. Here are the variables a, b, c, and then it's giving me an estimate of how good it is. And actually, this is very, very close to being cubic because that number is really close to 1. So my equation looks like it's going to be, now this, we wanted this to the nearest thousandth, so it's going to be y equals 0.005 x cubed, plus, the b value here is minus, so minus 0.388 x squared plus 10.227x plus 160. I'm getting close to the calculator here. 160, I got to move this over. 0.643. 0.643. Good. Now, there's my equation. Now, what I don't want you doing is plugging in the value of 50 into this. Okay, not what you've got written here. We're going to let the calculator do it, because remember, the calculator has remembered this equation. And so what we can do here, actually we can do this a couple of different ways. What I can do right now, I'll show you, actually I will show you a couple different ways of doing this. So the calculator has that equation in its memory here. What I want to do is I'm going to take x, I'm going to take x, but I'm going to store 50 in it. So 50, press 50, and then the store button is right here. I'm going to store that number in the x variable for right now. So when the calculator spits out an x, or when the calculator sees x, it's going to see 50. Now what I'm going to do, I'll press stat. We're going to go, oh sorry, not stat, I'm sorry, that's not what I meant to do at all. Vars, okay, I'm going to pull out the regression equation. So vars, we're going to go down to statistics, and then we're going to go over to EQ, and the very first option here is the regression equation. Now, look at what happened here. The calculator put it down to all of the decimal places that it can remember. And actually, I do believe that it does it to even more than that. I think that it carries in its memory even a few more than the numbers that it's showing here. But notice that it's got x in there, and that's the same x here. The calculator is going to recognize that as 50. And so now when I press enter, it's going to give me the answer of 362.69. Okay? So if x equals 50, y is going to equal 362.69. Now, that's one way of doing that. Here's another way of doing it. We're going to go to y equals, and I'm going to put the equation here in y equals. So again, vars, down to statistics, over to EQ, and because the cursor was blinking on y1 in the y equals screen, when I choose the regression equation here, it's going to dump the equation right there. Okay? And so now what I can do here is I'm going to adjust my window settings. I need to make sure that my x max is bigger than 50, because that's what I'm going to put in there. So let's put, I don't know, let's put 100, why not? And let's make my y max, well, my y values seem to go up to like, at 40 goes up to like close to 300. I don't know, let's make it 1,000. Probably going to go up even higher. And let's just graph it, see what we get. All right, so there you got that kind of the cubic feel to it. And now, to figure out what the x value is, I would press second trace, value, and now the calculator is waiting for me to enter an x value, so I press 50, and there it is again, the 362.69. Okay, two different ways you can use that regression equation once you've calculated it.
Shane tracked the depth of the water at an ocean marina one afternoon. His data is summarized in the table below.
Okay, so in this case right here, we've been given the scenario. Now we're going to determine the equation for a cubic regression. And x is the number of hours since 12 o'clock, and y is the depth in feet here. Okay, well, I've got to do some fixing here. If this is the time, I need the hours after 12. So this is going to be 0, 1, 2, 3, 4, whoops, 5, 6, 7. We're missing the one there. So I needed to adjust that first. Now I can go and enter that data into my calculator. Okay, so stat edit. So 0, 1, 2, 3, 4, 6. Yeah, because we're missing 17, so 6 and then 7 there. And then it was 12.3, 12.7, 13.3, 13.8, 14.3, 13.6, 14.3. So there's the data entered in. And now we're going to come up with a cubic regression. So I'm going to go back to the home screen here. Stat, over to calc, we go down to cubic regression. And then again, by default, it goes x and y here. And so that's the regression equation here. And we wanted to write this down. Actually, it doesn't say here. So just determine the equation for the cubic regression. Let x be the number of hours. Okay, so we're just going to write it out. And I'll probably write it out to the nearest, let's say, 100th here. So that's going to be y equals negative 0.02 x cubed plus 0.09 x squared plus 0.36x plus 12.29. Okay, so there's our equation here, except when I answer these next two questions, I'm not going to use this one. I'm going to use the one the calculator came up with. So interpolate the depth of the water at 7 o'clock. Okay, well, I'm going to do this the way I did it the first time here. Because I'm given here in both of these questions here, interpolate the depth at 17 and then here's at 10:30. What they're doing here is they're giving us x coordinates and asking us for y coordinates. Now, at 17, that would be 5. So what I'm going to do here is I'm going to put 5, I'm going to store that in x. Now I'm going to yank out that regression equation. Again, it's going to be vars down to statistics over to EQ. It's going to write out the equation here with x in it. And so when I press enter, it's going to put 5 in for x. And so the answer here, and we'll do this to the nearest tenth, will be 14.6. Okay, 14.6 feet. Extrapolate the depth of the water at 10:30 that morning. Okay, well now I got to think a little bit about this. 10:30, if noon is 12, then 11 is going to be, sorry, if noon is 12, that was sad. If 12 is 0, then 11 in the morning's got to be -1. 10 in the morning's got to be -2. So meaning that 10:30 would be -1.5. Okay, I've got to make that connection here, or else it's not going to work here. So now what I'll do here is I'm going to do basically the same thing, but I'm going to store -1.5. I'm going to store that in x. And now I'll do the same thing as before. Vars, statistics, EQ, pulls out the equation when I press enter. I'm going to get 12.0. Okay, so 12.0 feet is the depth at 10:30 that morning.
A research company summarized the average time spent every day by teenagers watching television.
All right, so for this question right here, we're given a bunch of data, and for the very first one, we're asked to come up with the quadratic regression here. So first of all, I'm going to put it so that you can see the data as I put it in here. So stat, edit, what we got here? 1999, whoops, 2000, 2001, 2002, 2003, 2004, 2005, 2006. Now, just so that you know, most of the time when we're doing a regression here, and we're using like years are the x value. In most cases, what we would do is we would do this with reference to a specific year. So for example, maybe we would make 1999 year 0, and then this would be year 1, 2, 3, and so on. It doesn't really matter. We're not going to be doing much with it at this point here, so I believe we're okay plugging in the actual values here, years. So 196, 190, 187, 185, 182, and then 169, and that should finish me off. Good. All right, now I'm going to quit. We want to do a quadratic regression, so stat, calc, we're going to come down to the quadratic regression option, number 5. Again, by default, it goes list 1, list 2, and that's good. That's what I want. Calculate. And here we go. And so now my equation is now, and again, it doesn't tell me what to round to, so I'm just going to round to its nearest hundredth. So we've got here y is going to equal negative 1.28 x squared plus 5,123.41 x minus, oh, that's a big number there. What is it? That's minus 5,127,584.63. Oy. Okay, That's fine. Now it says use your graph to estimate the average amount of time spent watching television in 2008. Well, okay, because I put in the actual year numbers into my list here, I can get away with just entering in the year numbers. So just like I did before here, I'm going to take 2008. I'm going to store that in X so that the calculator sees it. Press enter. Now I'm going to pull up that equation there. So vars down to statistics, over to EQ, going to grab that equation, so there it is with all the little details there. And again, because I've plugged in 2008 in for X, when I press enter, it calculates it, and the answer is 142.18. Okay, 142.18 hours. All right, so the model tells us that the amount of time spent per year watching television is decreasing. Good, good. That's right. Get out of the house, go enjoy life.